All right, here we go. Question number 7 from our 1316 homework number 2 in MyLab Math. They want us to graph the following function showing at least 2 cycles and use the graph to determine the domain and range of the function. So in this case, we have a tangent function. This is not sinusoidal like all of the previous problems we dealt with. And so in this problem, I'm going to get to demonstrate my 4-step method for graphing either tangent or cotangent, okay? So the process I'm about to lay out is for tangent specifically, but the process is similar to the way that you would do a cotangent graph also. Here we go. Step number 1, you need to know that this graph, since it's tangent, is going to be bounded between negative pi over 2 and pi over 2 respectively. The way I think about this is it says that theta can be an angle bounded between these two values in order to produce the graph, so that these boundaries here are going to be 2 consecutive asymptotes, okay? So from negative pi over 2 to pi over 2, depending on what theta is. Now theta is your angle, which in this case is x. And since that's already solved for, then we know that x is going to produce asymptotes at negative pi over 2 and pi over 2, and those will be 2 consecutive asymptotes. Now, step number 2, you need to know that there will be an x-intercept halfway between the asymptotes. So for every 2 consecutive asymptotes right in the middle, you'll have an x-intercept unless there's a vertical shift, which we're not going to run into that in this problem, okay? So there will be an x-intercept right in the middle of consecutive asymptotes. Step number 3, we're going to word it like this. At the first and third quarters, you're going to have y values of negative a and a, respectively. Okay? And I'll explain what that means in just a second when we sketch the graph. And the final step, we're going to play connect the dots. All right, so let's get us a coordinate system down here so that we can go through and demonstrate how these 4 steps lead us to the graph. Okay, so we know that step number 1 is all about finding consecutive, let me spell this right. Consecutive asymptotes. Okay, so at negative pi over 2 and pi over 2, we're going to have asymptotes, vertical asymptotes. So I'm going to say, okay, here's negative pi over 2, and then equidistant on the other side would be positive pi over 2, and we're going to draw in some asymptotes, okay? Vertical asymptotes. That's the first step. Second step, we're going to have an x-intercept exactly in the middle of those asymptotes. So right here at the origin, we would expect an x-intercept. And then now for step number 3, let me see if I can break this down for you. At the first and third quarters, that means if I come back here to my consecutive asymptotes, right now I've got this broken down into 2 spaces. 1, 2. If I break that down into fourths by putting hash marks here and here, then these become quarters. Okay, so this would be the first quarter, second quarter, third quarter, and then 4 quarters make a whole space. Do you see what I mean by quarters? It breaks it up into 4 spaces. Whoops, and I got rid of my my y-axis. There we go. So at the first quarter, we're going to be at negative a, and at the third quarter, we're going to be at positive a. Now, if I scroll up and look at my equation, I can see that a is actually negative 4. So if I plug that in here, minus a negative is going to make that positive 4. So at the first quarter, I'm actually going to be at positive 4. And then at the third quarter, I'm going to be at A, which is negative 4. And now I've got 3 dots. I'm going to connect the dots. And so these asymptotes are where the graph is going to approach but never touch. And we're going to expect the graph to come in and do something like this, to squiggle like that. Now, if I need another period, I can always go 1, 2, 3, 4, put another vertical asymptote, and then lay out my points again. Okay, so right in the middle, we have an x-intercept. At the first quarter, we're going to be up at 4. At the third quarter, we're going to be at negative 4, and then I can just come through and connect the dots again. Now, if I want to know what to label this hash mark, what I can notice is that let's see here. If I do this in black, here we go. So this hash mark is a half. So this hash mark must be a quarter, because a fourth and a fourth make a half. So each one of these hash marks is a fourth, okay? So count with me. 1/4, 2/4, 3/4, 4/4, which would be pi. 5/4, 6/4 would be 3 pi over 2, would be where the next asymptote goes. And then you can keep doing copy and paste and getting these answers, okay? So there's the graph. And then notice for this problem, I don't actually have to graph it. I just have to pick the correct graph. So we need a graph that goes through the origin and comes down from left to right. That looks like it could be A or B, but it can't be C because it's going up. And then, well, it could be D. But let's examine D real close here, okay? If you look at what D says, it says that at 2 pi is where this point right here should be. Do you see that in answer choice D? That second wave past the origin is touching at 2 pi, but in my hand-drawn picture, I'm only touching at pi, so it can't be D. D's not a choice. It can't be C, so it has to be either A or B, and that's going to depend on, let's see. Oh, I see what's different here. Look, this one goes up to 8, and this one goes up to 1, so it's about how steep the curve is. So this is up at 4, and so if I go another 5, 6, 7, 8, then this would be up at 8, and so it looks like this answer choice B should be correct because it's a lot steeper. It actually goes up to 8 here instead of getting really close at 1. Now, before I go with B for my final answer, I'm going to use a lifeline. I'm going to use Desmos to help me check this, okay? This is my lifeline, my phone a friend, which is Desmos, -4, P8NX. And we're going to look at what Desmos says, okay? And I can even set this window up to be the same as Desmos. I'm sorry, the Desmos window I can set to be the same as this. So I'm going to take answer choice A, and I'm going to come to my settings, and I'm going to take and make the x-axis negative 2 pi for pi, and positive 2 pi for pi. And the step, I'm going to make it pi. Now, for the y scale, the y-axis, I'm going to make this negative 1 to 1. And then if answer choice A is correct, then what I'm seeing in Desmos should be exactly what I see over here, and it's not. There's way more squiggle visible than there is over here, okay? So then I'm going to go back to the settings and change my y-axis from negative 1. I'm going to say negative 8 to 8. And then I'm going to compare this picture to B. And as you can see, I've got part of a squiggle, 1, 2, 3 complete squiggles, and then part of another squiggle. And that looks exactly like what I'm seeing in Desmos. So I feel really good about answer choice B now that I've looked at it in Desmos. Bam! There you go. Now, it says good job. Oh, it's also going to want more information. Okay, here we go. The domain. All right, so let's focus on the domain over here for a second. If I scroll down a little bit, we know the domain are the values that x can be, but at every one of these asymptotes, that is a number that x can't be. So if you notice the first asymptote, if I fill in the coefficient, that's negative 1 pi over 2. And then the next one is at 1 pi over 2. And then the very next one is at 3 pi over 2. Guess what the next one's going to be at? 5 pi over 2. Because these asymptotes are a pi apart, okay? So if I count by halves, 1/2, and then a half and a half would be 3 halves, and then a half and a half would be 5 halves. Can you see that these are occurring at odd values of pi over 2? 1 pi over 2, 3 pi over 2, 5 pi over 2. These are odd multiples of pi over 2. So then we can say the domain is going to be the set of all x's such that x cannot be wherever these asymptotes occur at. And we said that these asymptotes occur at odd values of pi over 2. So we're going to say pi over 2k, where k is odd. Actually, we should say k is an odd integer. Okay. Now let's plug in some odd numbers and see if that produces our asymptotes, which are values that x can't be. Okay, so if I plug in positive 1, 1 times a half is a half. If I plug in, now remember we're talking about odd numbers, so the next odd number would be 3. Pi over 2 times 3 is 3 pi over 2. 5 times pi over 2 is 5 pi over 2. So this is producing our asymptotes. So we're going to say answer choice A is correct because this fraction, k pi over 2, is the same as pi over 2 times k. Those are identical. Yay, so I didn't lie to you. And then guess what the range is? These squiggles, these graphs of the tangent, they go up forever and they go down forever. So the range is going to be all real numbers because it covers every value of y, from minus infinity going down to positive infinity going up, all real numbers. And I hope all of that was helpful. If you have any questions or comments, feel free to leave them in the comment section below, or you can text me. And thanks for watching.